We're now going to turn our attention to a type of weather pattern called a thunderstorm. Now remember, back in Module 7 we said that there was a certain type of cloud that produced thunderstorms, and that was called a cumulonimbus cloud. The cumulonimbus cloud was those ones that were really, really tall. Think about what's needed in order to get the cloud to be that tall. Well, you're going to need a large, what's called an updraft, a current of rising air. And so there are 3 stages to a thunderstorm. The first stage is where that updraft, is beginning to form. It's beginning to carry this warmer air with moisture up into the atmosphere. So the updraft then carries the warmer, moist air up higher in elevation, and that warmer air turns into colder air, and that's when those ice crystals start to form inside that cumulonimbus cloud. So this is called the cumulus stage. The second stage of a thunderstorm is where the cloud has pretty much formed, the cumulonimbus cloud. It's what we call the mature stage. What happens inside this cloud, inside a mature stage cumulonimbus cloud, is that we have a complete cycle of air. We'll have an updraft followed by a downdraft. And somewhere inside the cloud will be a boundary line where we have the freezing point of water. As the moisture rises, it freezes into that crystal, probably following the Bergeron process here, where the crystal begins to fall, and it can accumulate more moisture or fragment into pieces. If the updraft is strong enough, it'll carry those ice crystals back up to the top, and they'll begin their cycle all over again about getting bigger and collecting moisture. And so this cycle continues until the ice crystal is too large and it falls down through the cloud and eventually falls to the ground. When it crosses that 32 degrees Fahrenheit barrier again, that's when it melts into the liquid water and we get the rainstorm that we have here. So this is the mature stage. Then the final stage of the thunderstorm is when it is dying out. And basically we only have a downdraft present. This is called the dissipation stage. It won't be long now before the storm stops and the rain stops altogether. Without the updraft, there won't be any further accumulation of moisture there. So these are the 3 stages of a thunderstorm. Do you remember the pictures of the cumulonimbus clouds? Similar to this one here. The flat top sort of makes the cloud look like an anvil. Remember an anvil from the cartoons? The anvils are the one things that never fall in a straight line. Remember, as Wile E. Coyote is falling, he'll fall faster than the anvil. But then by the time he hits the ground, the anvil will move over on top of his head and hit him on the head. Well, where does that flat top come from? How does the cumulonimbus cloud produce these? Well, remember what's happening. We have an updraft of air. That air is moving up higher and higher, but it's going to stop moving up at one point. And the point that it stops moving up, that's the top of the troposphere. And so once the updraft gets to the top of the troposphere, there's only one place for it to go, and that's to spread out. And so these high winds cause the cloud to spread out on top. So the updraft carries the moisture up and up and up and up, but it reaches the top of the troposphere and can't go any higher, so then it spreads out over the top. So that's where that anvil effect comes from. Now, one of the most interesting things about a thunderstorm is this concept of lightning. Have you ever had a static electricity shock? Happens all the time where I'm from here. especially in the winter time because it's dry air. We take our feet and we rub them across the carpet. As you rub across the carpet, you're going to build up static electrical charge, and then you go and you touch something metal like, the doorknob or maybe the staircase railing or something, and zzzt, okay? Or you could either touch another person, zzzt, and you get zapped there. Well, the static electrical charge built up because you are rubbing your feet across the carpet, and so that rubbing action allows electrons to be transferred. Well, it's the same idea that's happening in a cumulonimbus cloud. You have an updraft of air and you have a downdraft of air. That updraft and the downdraft can act as a rubbing sensation, and electrons can be transferred. And so what we'll do is we'll have a buildup of charge in the clouds. Okay, you got a buildup of charge. And that buildup of charge then can attract the charges from the ground. So you got this buildup of charge in the bottom of the cumulonimbus cloud. We've got a buildup of another charge on top. Usually the positives are on the bottom, the negatives are on top. And so then that bottom of the cumulonimbus cloud starts attracting charges from the ground. And that buildup of charge is what we call the lightning, when the charges meet and the energy is transferred. And so here you can see this is a time-elapse photograph across the city of the different lightning strikes. Now this picture didn't happen all at one time. Those lightning strikes happened at different times, but they just left the film exposed during the whole storm. Here's a lightning bolt picture I've used before in the PowerPoint presentations here. All of those branches that you see are other pathways that electrons are trying to get to the oppositely charged particle on the ground. Okay, remember, these particles are going to try to take the path of least resistance. And so all of those branches that you see there are other electrons that are trying to make their own path, trying to find the path of least resistance. Eventually one path is going to make it, it's going to win, and the energy will be transferred. Here's another very famous photograph. Okay, this photograph was taken in 1902 near Paris, or in Paris, with the Eiffel Tower, when we had several lightning strikes that hit it. The Eiffel Tower has what is called a lightning rod system built into it, where these large metal copper wires are running through there in order to carry the electricity from the lightning storms, as the Eiffel Tower gets struck quite often.